Okay, friends, this is our last section of our chapter 2 of our review concepts 2.8, and this is graphing inequalities, linear inequalities, graphing linear inequalities. Okay, so you should have a piece of graph paper, and I'm going to go ahead. That's a terrible marker. Make a couple axes here, if you would. And you're going to need some sort of colored pencil. And I think I can sum this up pretty much in 4 graphs, okay? So all you're doing is you have an inequality, okay? And on the inequalities, okay, you are just graphing and then you're shading, okay? But keep in mind when you're graphing the inequalities that there's a couple things you need to, a couple rules that you have to keep in mind, okay? So one of the first rules is if it's less than or greater than, we use a dotted line, okay, instead of a solid line. If it's greater than, equal to, less than, or equal to, we use a solid line, okay? And we usually do a test point. So we're going to start out, we're going to graph something easy, okay? Y is, you guessed it, less than -1. Okay, so the first thing you want to do is think about how you would graph this, okay? So there is no xy, there is no slope. This is a horizontal line, and it goes through -1, okay? So I'm going to put a dot at -1. And before I draw my line, I'm going to ask myself, am I dotted or solid? You're right. I'm going to be dotted because it's not equal to, okay? Now, I'm going to use a marker. Actually, I'm going to use a red pen, okay? I try to use a test point, and I try to use the same one every time, and I'm going to use 0, 0, okay? So I'm going to use my test point 0, 0, okay? Now, there is no x, but I'm going to plug in a 0 for y, okay? Okay, does this make the statement true? Is 0 less than -1? No. So don't shade above the line, shade below. You always shade the side that is true. Okay, so that's a no, that's false. You shade the other side. Okay, so at any point down here, you can plug in one of those values. It makes that statement true. Okay, so that's your big thing. How do you know when to shade? When there's an inequality. All right, let's try one in slope-intercept form. Y is less than -x plus 2. Okay? Okay, so ignore the inequality and just think about y is equal to -x plus 2. Okay, so this is in slope-intercept form, right? Y is equal to mx plus b. So the y-intercept is 2. Okay, now what's the slope? Well, what's that number in front of x? You're right, it's a -1. So my slope is -1 over 1. So m is -1 over 1. That means down 1 and 1 to the right. Down 1, 1 to the right. Okay, before you get too crazy, okay, make sure you ask yourself, is this dotted or solid? Well, friends, it's got an equal to, so it's a solid line. So before you get, now, wonder if you draw it solid and it's supposed to be dotted. What can you can just write, hey, it's supposed to be dotted. Not a big deal. Okay, are you ready? I'm going to use my favorite test point. I'm going to use 0, 0. So I'm going to put my dot at 0, 0. This is my side with my test point. Then I'm going to plug 0, 0 in for x and y on my inequality. Are you ready? So 0 is less than or equal to -1 times 0 plus 2. Now, the reason I'm using all these colors is so that you can see where these numbers are coming from. Okay, are you ready? So, I'm going to go ahead. 0 is less than, what's -1 times 0? You're right, 0 plus 2. What's 0 plus 2? You're right, 2. Okay, is 0 less than or equal to 2? Yes. Pick, you always shade the side that has the yes. Okay? All right. Let's try one in standard form. So remember, in standard form, I can use the cover-up method. Are you ready? So 3y, just treat it like an equal sign. Divide by 3. What does y equal? A 3. Put a dot at 3 on the y-axis. 1, 2, 3. Okay, now let's do the x. Okay, 9x equals 9. Divide by 9. X is 1. Put a dot at 1 on the x-axis and connect. But before you do, am I dotted or solid? Dotted. Okay, that's always good because sometimes I get a little rammy with my graphing here. Okay, and sometimes I put arrows, sometimes I don't. It's not a big deal. Okay, not a big deal for right now. We're getting into the shading part. I want to make sure we understand. Okay, here's a test point. 0, 0, 0. All right, let's plug it in. We're plugging it in here and plugging it in here. Oh my, what do you think's going to happen? Well, this is 0 plus 0 is greater than 9. Is 0 greater than 9? No. So don't shade the side that says no. Shade the side that's yes. So shade the other side. If this side's no, well, this side's got to be yes. Okay. The last application is taking stuff from 2-7. So let's do an absolute value. No big thing. You guys are masters at this. Okay. So, are you ready? My vertex always starts at 0, 0, but this is telling me I need to go 2 to the left and 1 down. 2 to the left, 1 down. That's my new vertex. What's my slope? My slope is 2. 2 over 1. Up 2 over 1. And it's symmetric. So what I do to one side, I must do to the other. Now, before you draw your V, are you dotted or solid? Dotted. Awesome. No, solid. Whew, getting late. Gotta get my ruler. Good thing you guys are with me, huh? Now, you'll notice with like a line, it was one side or the other. With a V, you either shade in or you shade out. So again, I'm going to try my test point. My test point is 0, 0. What do I do if my line goes through 0, 0? Pick something else that's easy, okay? Pick something like 1, 1, okay? Something super easy for you to plug in. This one takes a little bit because you have to plug it into the Y, okay? And then you have to plug it inside your absolute value and actually calculate, okay? So this part is okay. What's 0 plus 2? Well, that's 2. What's the absolute value of 2? That is also 2, okay? What's 2 times 2? That's 4. And what's 4 minus 1? That's 3. Is 0 greater than 3? No. I'd rather have $3 than no dollars. So this is a no on the outside. So that means my shading is happening inside of my V. You always want to shade. So if it's no on the outside, then got to stay inside. No, you can't go outside. So you have to stay inside. Okay, thanks a lot, friends. Now it's your turn to practice.